development and resources dedicated to figuring that out. And one of the major ways that is generally talked about for doing that is you just get the source code for the object, right? Like you have a game and then you want to figure out how it works. And if you can get the source code, you get to learn more about how the system was architected and who designed it and how it works. And one example that I've looked into a little bit is MUD, which is the multi-user dungeon. One was actually added after it was made by Richard Garlow to make sure you knew it was the first one. It was essentially the first multiplayer online virtual world. It was text-based. It was made at the University of Essex in the late 1970s. And we have the source code here at Stanford. You can just download it off the website, which is kind of nifty. But if you look at the source code, it's actually kind of hard to parse. It's written in VCTL, which is a progenitor to the C language, designed by Martin Richards. And the version that MUD was written in was actually it was written between 1979 and 1986 at the University of Essex using the University of Essex's own implementation of the VCTL language. So getting this running again or kind of figuring out what's going on in the source code requires you to essentially get discordant references from different time periods to try and construct when certain things in the code had been written at what times. And there's absolutely no compiler for this, so if you actually wanted to try and run the thing again, even if you have the source code, you need a ton of other dependent objects just to get the game and the system running again. The other reference for VCTL is actually the language reference by Martin Richards, who made it. But this book is from 4 years after the University of Essex project started, so it actually includes a lot of references to things that were not available to people in 1979. Essentially the way that you figure out this works is you email Richard Garlow and some of the developers and kind of get into more of a conversation about how the system works, right? Like when you start looking into development practice and development records, you realize that when we're preserving the games in just a single object, you can't get at a lot of the history that you would otherwise need to get to, and so you need to fall back on more, tried and true methods like oral history and like direct contact with people. You can't just get. The other thing, just as a general problem with development studies that way, is that source code is very unavailable. There's actually a Wikipedia page devoted to commercial games that have source code available, because it's not that common. That's a really nice page to look at if you're interested in specific games or have specific things to develop. Most notable games with source code available, SimCity and Doom, which is actually something I'm looking into at this moment. The other problem is that there's not a lot of tradition for how to do the history anyway. There's no history of game development page on Wikipedia. There's actually a direction to it, and then it's just hanging there, right? So there hasn't been a lot of concerted effort, even within the development community, to kind of figure out how to preserve and talk about their heritage. We actually worked on a project, another joint project between Stanford and UCSC to kind of define that for archives. One of our notions was that if you kind of gave a guide for how to deal with the records of game development, maybe institutions would be more willing to actually take them on or deal with them or figure out how to appraise them. So from the two examples that I talked to with technology studies into the NES and getting into more development practice histories, the preservation of the game objects isn't basically enough. And even when you have those sources, they're kind of difficult to access and collect and describe in a level of detail that might be useful for specific people in those disciplines. Also, the technical study that technical study stuff that I talked about, where there's a lot of forms of preservation practice, like you're trying to preserve the games as objects, but you need a lot more of the historical context around them to be preserved as well, in order to get a more fuller understanding. And it also privileges a specific type of historical analysis. The game data that you save lets you only do a certain number of things analytically that you need to then supplement with other types of preservation practices and other types of historical study. And another large thing which kind of came out of the MUD example for me personally is that when we do the preservation work, there's not a lot of discussion or there's not as much discussion as there is of how difficult it will be to deal with, the technical considerations of objects at the time that you're preserving them, or into the future. The MUD example for me actually kind of kicked off the last part of this talk, which is it's a distributed, multiplayer online game that's server dependent, so there's a lot of specific technological dependencies that we can never reclaim to get that thing to run again. Like it'd be a very, very Herculean effort to actually get Mud 1 running. Luckily for Mud 1 specifically, it was actually ported to C, so if you want to cross-compare between the C version that works and the VCPL version that doesn't, feel free. I'm sure there's actually quite a lot of interesting stuff in there from a programming languages perspective. Essentially, all the stuff that complicates that standard preservation model has significant implications for the future. So I guess the last third of this talk is kind of dedicated to this notion that the standard perception of game preservation and game history is rapidly changing, and it's fast becoming outdated. When I think of a game being born in 1983, my historical center for them is like the Nintendo Entertainment System. It's where I first got exposed to video games and how I kind of like demarcate game history for myself internally. And when I think about preservation practice, I just used it earlier in the talk as like a standard, one of the objects for the standard preservation model that we kind of developed for the research that we've done. That's a very North American-centric view. If I was born in 1984 in some other country or other part of the world, Nintendo would not be my defining object for my history. It would be something else like a Commodore Vita or the Famicom, which is the Japanese version. But the thing is that a lot of the work in preservation is being thought of and conducted with a mindset towards these types of objects. And then whenever I think about people who are, grew up later, were born in 2000, some people in this room who are much, much younger than I am, right? Like, this is a conception of a game, to vast numbers of people in that generation. And this is a very, very different preservation object and a very, very different, model for both software and interaction. So if we kind of look at the standard preservation model that I brought in the beginning, where you have data that's put on the storage media that's conveyed to a platform, if you throw a phone into this, it gets a little buggy. There's no storage media. It actually kind of gets data put on it from the internet, and so there's a totally different distribution paradigm. There's a different reliance on network connections and sort of other dependent systems that was not present in the earlier preservation, conceptualization. And so I'm kind of referring to this as like a network contingent model for preservation. And there really isn't a lot that this stuff, like we don't know how the previous perspective that we had on this maps to this new paradigm. Really yet. Like, some of the description and canonicity issues are always going to be there. Migration and storage for digitally distributed or highly networked objects is kind of really big open question still. And then representation is also a big problem. Because if you have all these things that were dependent on a network connection for distribution and update, a network connection for playing, a network connection for interaction with other people, when all that goes away in a decade, the object's not going to function, even if you get the whole code back, if you get the whole object, if you do this whole thing that we talked about with getting the data, off of or out of the digital distribution system, and you store it on your local computer or your local repository. The representation issues are different. The emulation challenges are also different. And for, I guess, just an expression of some of the gravity of the issue of this, the gravity of this kind of issue, if you start with a basic idea of the development of games or, interactive software from 1950 till now, and you think about stuff in the standard model, there's been a kind of just a growth going out. And then for network dependent stuff, it starts later, right? And so we're kind of, in this space right now. This is highly empirical, by the way. But if you kind of set it out, you kind of go out from here, for the future of humanity, most of the software objects and games that we're going to need to be saving or talking about are going to be, in this newer model that doesn't really comport as much with the standard stuff that I was talking about and the standard practices that we've developed over the last, 20 years. And this kind of happens again with the physical distribution of objects as well. Like you had distribution of physical items that has been, teased and slowly killing off, and then digital distribution comes in and effectively takes over, going forward, right? So like we're not going to have as many physical items to cataloging anymore. Everything's going to have to be focused on how to store things in digital systems and get them out of digital systems and get them out of, iStore walled gardens, and things of that, and like other similar places. And this isn't like that, I kind of phrase this as being scary or daunting, and it is, but it's also backed up by some numbers. So if you go to Moby Games, which is a site that kind of has right now what would be a canonical listing of the games that exist, there's about 55,000 games for all platforms for all time listed on Moby Games, right? Of those, about 19,000 are Windows games for all versions of Windows. If you look at Steam's current numbers right now, there are 9,000 Windows games on Steam, right? So half of the Windows games, so not half, around half in weird math world. A significant percentage of games that have existed for Windows exist right now and are in this newer preservation model, are in this newer network contingent world. And it gets even kind of crazier with the iOS App Store. This is like recent statistics from last week from Hot Gamer. There's 534,000 active games on the iOS Store, with 207 being added every day. So there's effectively an order of magnitude more games on the iOS platform right now than have existed in recorded history for human production. Now, mind you, the games on Moby Games listing also includes iOS apps in it, so the Moby Games listing is actually like kind of an overlap here. And I guarantee you that a significant percentage of those 500,000 apps are not very good or compelling. But again, this gets back to the earlier point of description and canonicity, is that I don't know if there's some future great individual who's making some terrible app right now that we might want to save, because at some point in the future, that'll be kind of a historical, interesting technical object. And so this gets into this weird inversion. I used to, when I gave archiving talks, talk about